The MPX Modal Explorer is the encircled flux meter of choice for leading companies around the world. Encircled flux is a measurement used to describe the amount of modal filling in a multi-mode optical fiber. It is defined as the proportion of the total optical power carried in the fiber which is contained in circle of a given radius. A typical plot of encircled flux shows the optical power as a function of radius, starting at the optical center of the fiber. Encircled flux is now used by various standards bodies such as IEC, TIA, and IEEE to set limits on the allowable modal launch conditions for applications, such as measuring loss of optical cables in data centers. The standards usually define upper and lower values of encircled flux at a number of radial positions. You can use the MPX to measure the modal filling of an optical fiber in real time. First, connect your source and patch cord. Here's how. The Modal Explorer comes with a variety of adapters to connect your power source to the instrument. Insert the connector into the adapter, then switch to Inspect mode. Adjust the focus and the indicator ensures you get a precise focus of the end face of the fiber. This is important for the accuracy of the measurement and for better repeatability between different operators. Switch on the light source and go into Measure mode. Optimize so that the exposure time is correct and you're looking at a real-time measurement of the encircled flux coming from your source. You can see the encircled flux plot with the pass and fail criteria. There's the encircled flux difference plot. The dotted blue lines indicate the upper and lower boundaries of the IEC 61280-4-1 template. You can also select IEEE templates or create your own custom templates to meet your own requirements. The table of EF data shows the currently selected template limits at each radius, real-time encircled flux values, and a visual pass-fail indicator. The instrument is real-time, so you can adjust modal conditions easily. If we squeeze the patch cable, you can see the encircled flux distribution changing as we do so, and the USB connection means this is a practical and portable tool. And you don't need to send the MPX away to be calibrated. It can be provided with a geometric calibration artifact so that you can check the geometry and magnification of the device at your own premises. If you want to measure coherent sources such as VCSELs or Fabry-Perot lasers, you may need to average for several seconds while shaking the fiber to break up speckle patterns. In this case, you can use the option Fiber Shaker. We offer the MPX-1 measuring at a wavelength of 850 nanometers and its heavier sister, the MPX-2, for measurements at 1300 nanometers. The MPX is a fast and easy way to determine the encircled flux of your light source.